Okay. So, we're going to first talk about angles in a circle. Angles in a circle. All right, so I'm going to draw a picture here. Is it weird because you're not sure where the angles are going to come from? Okay. You'll see. Okay, so we're going to call this circle circle C. Okay. Circle with center C. Okay, and we'll draw some other pieces in as well. So we will draw a point right here and a point right here. And we'll call this point A and this point B. It's coming. And we're going to connect A and B. Okay. And so then this segment AB, what could we call that segment AB? It's a what kind of segment in this, because it's a circle? It's a chord, right? AB is a chord. AB is a chord. Whereas if I draw AC, what is AC?
A radius.
A radius, that's right. Okay, so right now we've got a chord in the picture here. AB, this is just for some review. Right, we have a radius. That would be AC. Okay, I'm going to draw one more point in here, sorry, not two, one more point in. And we'll draw in a point D. And we'll also connect that to B. And from D to C. Like that. So then we have now another chord in our picture. What's the other chord we have in our picture now? Yeah, BD or DB. And what's our other radius in the picture? CD or DC, whatever you want to say it. Okay. A CD, listen to one? Maybe later. Now, we also have some angles now in this picture, right? For example, we have an angle ACD that we're going to focus on here. We also have another angle that we're going to focus on, ABD. Technically, yes, there's other angles here. For example, BAC is another angle. We are not going to worry about that. And CDB, we're not going to name that. But ACD, okay, we're going to name that angle. That's a special kind of angle. And so is ABD. It's another special kind of angle. So, ACD, you guys can actually probably figure out what the name of this is. Okay, the vertex, where is the vertex of this angle located? What's the vertex of this angle? C. What else is point C? It's the what of the circle? The center. So this is called a, ready? Central angle. That's all this is, okay? So central angle. Okay, so what makes a central angle a central angle? So I'm going to scoot this over here some. So, a central angle is an angle less than, thank you, sir. Listen up, please, folks. We're not done yet. Listen up, please. A central angle is an angle that is less than 180 degrees, okay, whose vertex is at the center of the circle. Okay? So that's a central angle, an angle less than 180 degrees whose vertex is at the center of the circle. All right, so that's angle ACD, right there, ACD. You can kind of see it. Scoot over there. There you go. ACD. Central angle, because the vertex of the angle is the center of the circle. Okay, the vertex, the point of the angle is at the center of the circle, and so ACD. So angle ACD. Guys, I am not going to talk over you. I know that we've had a long day, and we have to continue on, and I know that's a lot to ask, okay? You're not used to this, and thankfully this is the last day we have to do it, but we do have to do it. So please, let's just get through this, okay? Angle ACD, okay, is a central angle because its vertex, right, the pointy part of the angle right there is at the center of the circle. That makes it a central angle. Okay, now, the other angle I wanted to name here, angle ABD. Okay, so what's special about this angle? Well, again, this angle is perfectly kind of inside the circle right here, right? ABD. The vertex is on the circle, and so we call this an inscribed angle. Okay, because the angle is kind of inscribed in the circle.
But it's not touching the center. But it's not like one of the angles is not at the center.
Right. The vertex is not at the center, it's on the circle. And that's the key, okay? So an inscribed angle is an angle... Here, this pass came for you, Courtney, so you might want to head to the nurse. An angle whose vertex... Okay, is on the circle. So the point of the angle here is on the circle. So inscribed angle, an angle whose vertex is on the circle and whose sides are chords. And the sides are chords. Okay, so AB is a chord. Here, I'll let you finish writing that down, then I'll show you the picture. Okay, so an angle whose vertex is on the circle and the sides are chords. So you look here at the picture. I'm going to just zoom out so you can kind of see this. Okay, so ABD, right, the sides are chords. AB is a chord, BD is a chord, right, and the vertex B is on the circle. So that makes it an inscribed angle. Okay. Inscribed angle. So right, we have a chord, and then the vertex is on the circle. Okay. Now, that's the special angles that we're going to talk about. We're also going to talk about something called arcs. Okay, so we're going to talk about arcs in a circle. Okay, so it's not arc like Noah's Ark, right? Okay, arc. Wow, I said cycle. Okay, arc, A-R-C. I'll draw another picture here. We need another picture. Okay. And I'll draw some other pieces here. Okay. So there's another picture. Okay, so now arcs. When I say that word arc, okay, what do you think we're talking about now when I talk about an arc? Yeah, Alex, what do you want to say? Okay. Yeah, like a curved line, right? I mean, when you guys like think about like the flight path of like a baseball, if you're throwing the baseball kind of arcs through the air, right? It's not a straight line, right? It kind of makes an arc. It's curved, right? It's a curved path. And so an arc is just a piece of the edge, the outside part of the circle. Okay, so for example here, from A to B, okay, from A to B, we can name that using AB, and we're going to draw a little arc above it. Okay? And so that's kind of like this arc right here. Okay? That's that arc right there. Now, some of you maybe are thinking about Mr. Whitmire, arc AB, if we talk about arc AB, we could talk about this arc, AB, but why isn't it A all the way around this way to be this way? Why isn't that arc AB? Yeah? There are points in between, okay? When we name an arc with only two letters, we always go for the shorter path. So naming an arc with just two letters, you always take the shorter path. So in this case, you want to talk about AB. And this shorter path, okay, is called a minor arc. So AB with just two letters, okay, that is a minor arc. Okay, minor arc. Okay. Now we know the distance the whole way around the circle is how many degrees? What's the degrees for going the full way around the circle? How many degrees is that? 180. 180? 360, right? Yeah, 360. So if like one of your friends is ever like, yeah, man, I did like a total 360 and just changed my life around. Well, it's like, no, if you do a 360, you're right back to where you started, okay? You do a 180, that's when you make some changes in your life, okay? So make sure, it checks out. So anyway, 360 is a full way around the circle. So to be a minor arc, we need to be less than half of that, which is 180. Okay, so a minor arc is less than 180 degrees. Okay, it's less than 180 degrees. By the way, the measure of angle ACB. Okay, the measure of angle ACB here, how do you think that compares to this arc that's cutting out? So again, ACB as a central angle, right? This central angle is cutting out arc AB. Guys, eyes up front. All right, cut it out. Whatever you're doing, stop being silly. This is important, okay? Angle ACB, central angle ACB is cutting out arc AB. What's the relationship there between those two things? What do you think it is? The measure of this angle, how does that relate to the measure of this arc? Yeah?
Because it's less.
It'll also be less than 180 degrees, and in fact, these two measures are going to be the same. They're equal. So the measure of angle ACB, the angle is the same measure as the arc.
This is only different is it's like angle.
Correct. They both use degrees, though. The measure of the arc and the measure of the angle, they both use degrees. Okay? So AB, this arc, right, is a minor arc. It's less than 180 degrees. But let's talk about the other arc that goes around the opposite part of the circle there. Okay? So that would be, let me see if I can get like a different color in here. I had my other pen. Yes. So now let's talk about this arc. Okay, I don't want to like color on my picture itself. Let's talk about this arc. It's there. Okay, so like from B through D, or B through E through D to A. Okay, to name this arc, we're going to use three letters. Okay, so and it doesn't matter. Well, we got to start with B, so we'll say arc B. And then you can say BE, and then we have to do to A, right? So you can either say BEA or BDA. Either one there is fine there to name it. So you can say BEA or BDA.
You can say AEB or ADB.
Or ADB or AEB, that's fine too.
BS. Or BS.
Okay, so really there's four ways to name this other arc. Either ADB or AEB. Okay, you need to have the A and the B in there though, because that's the starting and stopping point. Or if you start at B, it goes B to E to A, or B to D to A. Now, AB was less than 180 degrees. We called it a minor arc. This arc right here that goes from A to D around to B, is that going to be less than 180 degrees, more than 180 degrees, equal to 180 degrees? What is that? ADB or AEB, what will that be? Will it be equal to 180 degrees, more than 180 degrees? It's going to be more than 180, that's right, exactly right. So what do you think we're going to call this kind of arc? Major, exactly right. It's a major arc.
The minor league and the major league.
Major league and minor league, that's right. So BEA, arc BEA is a major arc. Okay, major arc. And it's greater than, it is more than 180 degrees. Okay, more than 180 degrees. Okay, the measure of, and here's, oops, sorry, not measure of angle. The measure of arc BEA, okay, ready for this? So if we want to find the measure of arc BEA here, well, we could add up all the pieces, right? So you could add up the measure of this arc plus this arc plus this arc, whatever. But it's also equal to 360 degrees minus AB. Right? If BEA goes this way around the circle, then you can just do 360, the full circle, take away that part AB, right? So 360 is the full circle, take off the AB part, and you're left with what this piece has got to be. Okay? Questions on any of that?
Wait, how would we have to solve that? Do we have to measure it?
So you'll be given numbers, like in a picture or something like that, and you'll see. It'll make more sense there when you see that. And you'll see here in a second. Okay? Next. Last name. And actually this is the... Oh, we have one more thing. Yeah, one more thing we're talking about. So, last arc name, and then we have one more little theorem. EDB. Okay, so if you look here at arc EDB, what's special about arc EDB?
It's exactly 180.
It is exactly 180 degrees, right? It is half of the circle. What do you call half of a circle?
A semicircle.
Semicircle, exactly right. So arc EDB is a semicircle. Okay? Semicircle. Okay? Exactly 180 degrees. Okay? EB, therefore, is what special segment? A what of the circle? It's the diameter. It's a diameter, or also a chord, if you want to say that. So a chord that goes to the center. So since EB is a diameter, that means it creates this 180-degree semicircle arc. Okay? All right. Last thing here. So the central angle theorem.
The cat.
It's so easy. No, it's super easy, okay? Okay? It's simply this. The measure of a central angle, and this may not be a theorem, it might just be a postulate, but the measure of a central angle of a circle is equal to the measure of the arc it cuts out. Okay, that's not really like geometry terms, but I think it's better than saying intercepted arcs. Okay? The measure of a central angle of a circle is equal to the measure of the arc it cuts out. So for example here, if angle ACB is 60 degrees, what's the measure of arc AB?
30.
Careful, the measure of a central angle of a circle is equal to.
60.
So 60 as well, that's right. So if angle ACB is 60 degrees, arc AB will also be 60 degrees. If angle ACB is, 45 degrees, what's the measure of arc AB? 45. If arc AB is 50 degrees, what's the measure of angle ACB? 50. Yeah, they're equal, they're the same thing. Okay? Last theorem, and then I'll get you guys started on the assignment here. The inscribed angle theorem. Sorry. Thank you for saying something. Okay. The measure of an inscribed angle of a circle is, now this is a little bit different. So let me look at this picture here real quick if I can. Get both things up there, okay?
Hey guys, everybody, stop. Done. Don't watch, no, everybody. Okay?
We're almost done here, folks. You just got to hold it together for a few more seconds. I know your sanity is like at its limit because this is a way longer math class than you ever wanted to take in your life. But we got to get through it. This is the last day we got to do it. We got to do it. So, we don't really have an inscribed angle here. Let me go ahead and draw. All right, so I'm going to draw in an inscribed angle here in my previous picture. So take a look, folks. So again, I just got done saying that, for example, if we know that arc AB here is 50 degrees, we know that angle ACB is also 50 degrees, right? Central angle is equal to the arc it cuts out. But then if we look at this inscribed angle right here, right? This is an inscribed angle, right? The vertex is on the circle. Notice that this inscribed angle cuts out the exact same arc, right? It's the exact same arc as the central angle ACB. Now, again, if AB is 50 degrees, that means the central angle here is 50 degrees. But does it look like the inscribed angle is going to be the same as the central angle here?
No.
In fact, it looks like the inscribed angle will be what?
130.
So you think this angle here is bigger looking than this angle? It looks smaller, right? It's smaller. Anyone want to guess how much smaller?
Half.
Half, exactly right. So if arc AB is 50 degrees, the central angle will also be 50 degrees, but the inscribed angle will be 25. Half. 25. So, the measure of an inscribed angle of a circle is half, whoops, I'm going to a different color here accidentally because my student is half the measure of the arc it cuts out. Okay? So that means if arc AB is 100 degrees, what's the measure of angle AEB? If the measure of arc AB is 100 degrees, what's the measure of the inscribed angle AEB? 50. What's the measure of angle ACB?
100.
100. They're the same. Okay? If the measure of angle AEB is 20 degrees, if the measure of angle AEB is 20 degrees, what's the measure of arc AB? 40, and what's the measure of the central angle? 40. Okay, last question. If the measure of angle AEB, this angle is 22 degrees, what's the measure of angle ACB going to be? 44. That's right, because again, you doubled the inscribed angle to get the arc, and then the arc is the same as the central angle. That's it. Okay. Woo! We made it, folks.
Or did we?